Okay, the next problem we're going to do is problem number 12.50 on page 403. Again, this is a question where the sample statistics are in the back of the book in Appendix A. If you look at the Appendix A, you find the sample variance S squared is 270.58. Our sample size is 25. We see the problem that we're testing whether a variance assumption by the scientist is correct. The assumption is that the variance is equal to 250. And in part A, we're looking specifically at part A here, we're asked, do these data provide sufficient evidence at the 5% significance level to infer that the assumption is wrong? Okay. So reading that question, that tells me I'm just trying to find out, first my null is that the variance is equal to 250. And our alternative is we're just trying to figure out whether that assumption is wrong or not. We're not specifying less than or greater than. My alternative is a two-tail assumption, or two-tail alternative I should say, where the population variance is not equal to 250. So that's our hypotheses. Our next step is to look at the rejection region, figure out what that is. And again, you have to be careful. This is now a new distribution. This question is asking about variance, and so we're looking at a chi-square distribution. And it looks something along the lines of that. And this is where we need to determine, first off, our type of test, and secondly, our significance level. So type of test, we see it's a two-tailed test. And so that means I'll have rejection region in both tails, both to the left, and rejection region to the right. So I know I have two critical values I need to find, critical value A, critical value B. And secondly, my significance level is 5%, and I need to split that 5% between the two tails, and so that means I'll have 2.5% in this tail, and 2.5% then in the right-hand tail. Okay, so let's first look at critical value A. Actually, before I do that, let's look at the degrees of freedom. V, as we've said before, is the sample size minus 1. Here, sample size is 25, and so 25 minus 1 is 24. And so this first critical value, chi-squared. Now remember, with chi-squared, the subscript is the right tail probability. Here, so we have 2.5% to the left. That means our right tail probability is 0.975. Again, we have 24 degrees of freedom. So if you look over our table for 24 degrees of freedom, and a right tail probability of 0.975, we see that value is 12.4. Okay. So our critical value A is 12.4. Critical value B is a chi-squared now with 2.5% right tail probability, so I put 0.025, comma 24. And going again to that 24 row, we see that value is 39.4, I believe. And so these two critical values tell me then that my rejection region is when my test statistic is either less than 12.4 or when the test statistic is greater than 39.4. Okay, so those are the value ranges that will lead me to reject the null. Okay, so now we're left with finding the test statistic. And remember, test statistic formula is chi-squared equals n minus 1 times the sample variance divided by the hypothesized variance. And so here, n is 25, so 25 minus 1 times our sample variance, we were told is 270.58, divided by hypothesized variance is 250. And we do that calculation, I came out with 25.98. Okay, and so then I look, does that fall in the rejection region? Well, it's not less than 12.4, neither is it greater than 39.4. Therefore, we know that the test stat is not in a rejection region. Therefore, we fail to reject the null. And remember, for these type of questions, I said we do not need to know how to do the p-value, so we can pretty much stop right there.